Assalamualaikum viewers, this is our video about Synteny analysis. Although we have already made the video on Synteny analysis, but some of the viewers have some queries about the analysis, like how we know that which gene of one species is the ortholog in another species. For example, here when you do the dual Synteny plot, so you got this type of figure. So here we have this line. It shows that this gene is the ortholog of this gene of this plant species. But we didn't know the name of this gene, that what was this gene is, what is the name of this gene is, or here is also in this way that we know that these genes have the ortholog of this gene, or this have this gene, but we didn't know the exact name of that gene. So in this video we will try to know that what is the name of this gene that have the ortholog of this gene in another species. And the second theory was that most of the plant species were not fully sequenced and have a lot of scaffolds. When we do this Synteny analysis, these scaffolds show in the figure that have lot of number and look not good. So how to remove these unwanted scaffolds? Like in this picture, the genome of this plant species have a lot of scaffolds that are shown in the black region, while the chromosomes were shown in the brown region. So we need to delete these scaffolds to make this figure more pretty or more beautiful. But in this way, the presence of these scaffolds make this figure a little bit not good. So how to remove these scaffolds from this picture to make it more clear? So in this video we will try to answer these queries, that how to solve these problems. So how to do? Let's start. First you need to open the folder where we have these three files that we have generated in the previous video of the Synteny analysis. If you want to know that how to generate these files, so you need to watch that video. The link of that video is present in the video description, and also you can see at the end of this video. And open the TBTool. Go to the graphics, Synteny visualization, dual Synteny plot for MCScan X, and put the respective file in the respective column or the respective place. That here we need a CTL file, so drag this into the GFF here and collinearity and start. Here you see that the genome of these two plant species have the collinearity or Synteny region, but now we want to show that which one of our genes. So here copy this list of your genes and paste it in this box and start. So here you see that these are our genes or gene of studies. So how we know that these genes, the name of these genes have the ortholog with this gene? So here you can see that get highlighted gene in of genome. Click on here, so you can see that the first one, that on its chromosome, the this one is gene. Here, this one. The name of this gene is this one, and here this gene, and in the rhabdosis genome, it's orthologous. Here, this one. So you need to copy and paste it into your respective file where you are keeping your analysis, and save it. If you want to show these names in the figure, so you need to first save this figure. Now open that figure, copy it, and here in the 50 file you can paste it. And now you want to give the name of each gene. So here you see I want to give the name of this gene. So here I can check that it is on chromosome 12. This one locker. So you can copy this name here, go to paste, and here you can change the size whatever you want, and now you want to write the name of its orthology rhabdosis. So copy the name of, yeah, this one is this ortholog, copy, and give the same font as you have given. So this is the, and this one. Okay. So in this way you can give the each gene name to each one and their respective place. And after giving the name to all these genes, so you can select all and make a group and use this figure into your manuscript or where you want to use it. So in this way you will know the name of each gene. Hopefully it will give the answer of your this theory. Now we go to our second theory, which is about the unwanted scaffolds. So for that I have these three files in which they contain the unwanted scaffold. First you need to copy all these and paste it in another place, because you must have the backup of this file, because during editing or deletion, if you lost something, so you must have the backup. And first we use these files to make the dual sentence plot to check whether they have that unwanted scaffold or not. If have, then we will try to remove them. So first drag all the files in their respective place and stop. Here you see that there is a lot of scaffold present in this species, and these are the chromosomes. But here we didn't see the name of these scaffolds. So how we know that this is the name of these scaffold or these chromosomes? So to know the name of these scaffold or these chromosomes, you click on this chromosome or scaffold. So you see the name of here. This name is this one. So you need to write it in the copy one by one. Here is also a NC. This one is also NC. If you want to click on scaffold, it is NW and other is name. By checking this, we have noticed that the chromosome name was started with NC, while the scaffold name is started with NW. So we will remove these NW from our that file. But here you see that some of the scaffold like this one or this also have some regions that have the collinearity with this another genome. So we need to keep these scaffolds as well. So you need to copy this or write it into the file in this file right over here NW 004530317 like this. So yeah, this one NW 004530317. After noticing their name, so you go to the this open the file CTL. Yeah, you need to open the CTL. So here you see that all these scaffolds present. So first you need to delete them. How to delete? Or here you also have the NC, it means your chromosome name. But how to find that? It is first I want to find the scaffold. So copy and paste FV on this one. First yeah. We know that our chromosome name was started from NC. So press the cursor in the start and F control F and type NC. So you can see that this is our chromosome. These are scaffolds. So we need to select and remove. Now you remember that after one chromosome we have our scaffold like this one. So copy this one. So you need to copy this, copy, and here you can paste it. And another scaffold, paste right at the start of the cursor, and then copy up till comma and paste. Third one, copy. So we have copied our all the scaffold. Now we need to delete other scaffold. So how we will first try to find the our chromosome. That was start with NC. Right here NC. This one. So we have the three scaffold. So let's start. 1, 2, 3, and 3. Now another chromosome. This one. Another one. By doing this, you can also double check that whether in this region there is no other chromosome NC. When you select this, so keep the cursor at the start of that end and finish it at the end of this end. So this region must be selected and then deleted. Now you see that this region is here, this one is from here to here is all scaffold. But remember that after that there is no comma, where earlier when the name of one scaffold or chromosome finish it is separated with comma. So it means that these chromosomes are of another species. So when you delete it, so you also need to delete that comma as well. Press enter to make it into separate place and then save it. And cross. Now use this file, TTL file, in the respective place and start. Sorry, to differentiate between the chromosomes of two species, you need to make a space or enter. Anyone you want to differentiate between two. So here make the space, but there is no comma between these two. Here you see that these are the chromosomes of the same species, but we have separated them from comma. When we start writing the name of the second species, so you can separate it with space and save and then use this ETL and start. Sorry for inconvenience that you need to separate these the chromosomes of two species by press enter. The chromosomes of the same species were separated by comma here or here, but The chromosomes of the two species were separated through specific intro and then save it and use this file in the respective place and start. So here you can see that all the scaffolds unwanted scaffold was removed and these chromosomes were shown in the figure. And these are the scaffolds that we have kept because these also shown some Synteny or positions. If you want to remove them also you use that method. And then after that you will use your respective gene list in this box and then start so you will see your genes in this region. And also you can edit these colors from here. So this is our video about the queries that we have received from our viewers. Hopefully it will give the answer to their question. If you have any other queries, so let us know. So we will try to solve them. Thank you.